Resveratrol, a molecule, a supplement that was popularized by Dr. David Sinclair, is one of the most controversial yet fascinating supplement and molecule for longevity and health on the market today. Is the supplement a hoax or not? It's a serious question that could impact our long-term health, longevity, and our pockets, especially if we reach the wrong conclusion. This series investigates whether Dr. David Sinclair's conclusions on resveratrol were wrong, whether resveratrol helps your body stay young, and the secret mechanisms by which it works. On the way, we're gonna gather massive insights into how our bodies works, how plant molecules affect our systems, and how can we live longer. Now, let's start. Welcome to the Wellness Messiah podcast. I'm your host, Rimon. If you're here, you're part of the longevity community. People like yourself who are intelligent, responsible, will think for themselves. You get longevity. You know that you can achieve all the health and wellness goals by simply targeting longevity. And I'm exactly like you. I want to be the healthiest that I can be, as long as I can. And in the last 3 years, I've been taking 1 gram of resveratrol day on and day off. This dose is based on what Dr. David Sinclair took himself. I mean, heck, he actually ran the longevity studies, saw it in his eyes, and he's a super smart person. So taking what he takes is the safest bet, no doubt. But then, very recently, something happened, and I decided to revisit Dr. David Sinclair's own study. There, I discovered something I did not expect. The story goes like this. 2 months ago, I published a video clearing away confusion about conflicting studies on resveratrol, studies that Dr. Brad Stanfield showed in his channel. In that video, I included a segment where Dr. David Sinclair explains in his words what he found in his resveratrol study.
This is what's not known, though it's in the supplemental data of the paper that nobody ever reads. The mice that were given resveratrol every second day on a normal diet live dramatically longer than any other group. So people out there, my critics say, resveratrol didn't extend the lifespan of mice on a normal diet, therefore it's not aging, it's just protecting against a high-fat diet. Well, look at the supplemental data, please. If you give it to the mice every other day, we had mice living over 3 years.
Apparently, this channel has incredibly intelligent subscribers. One of them asked me the link to Dr. David Sinclair's supplemental data. David said I could not find that data in the supplemental material. A shout out for David Eddington for that. And I thought to myself, you know what? The research I showed in the Stanfield Sinclair video, I had done for myself in 2019. And I was curious to look again at Dr. David Sinclair's studies with the supplemental data. And you know what I found? Something I never expected. And I never heard David Sinclair mentioning himself. What did I find? Well, let's search for the study, and you can see in your own eyes. So this is the original study. Resveratrol improves health and survival of mice on a high-calorie diet. I couldn't find the supplemental data here, and I noticed that it says analysis of other groups will be presented at a later date. So I assumed I'm gonna find it in a different study. And indeed, in 2008, I found the correct study. This includes the supplemental data that Dr. David Sinclair mentioned in his video I showed you before. Let me tell you why this study is so unique. And I love this study because, first of all, it's a lifespan study. It's tracked the mice throughout their entire life until they die. Second, they used a group of mice that were doing intermittent fasting, an intense type of intermittent fasting. They fasted for 1 day and ate in another. And third, they tracked the trifecta of longevity, maximal lifespan, mortality, and health span. Reducing mortality means that on average we live longer, and health span means that we end up with a healthier body all throughout until the end. But maximal lifespan, how far we can potentially live, the maximum reach that we can achieve, is more of the potential of length of time that is available for us to live, not a guarantee that we're going to reach there. We are going to reach it if no disease takes us down. Maximum lifespan is the most difficult task of longevity research. So let's see what they found in the study. Now this graph shows mice on every other day feeding. If you notice this blue line, it represents low resveratrol. As you can see, they have the lowest mortality and live the longest. And you can see the delta, the difference between this blue line to other lines. On the other hand, the pink line, which is high resveratrol, about 4 times the dose, has a higher mortality rate than low resveratrol. And indeed, in the supplemental data, they mentioned that as well. I'm quoting, the EODLR, which stands for every other day feeding low resveratrol, had the longest survival. So I was thinking to myself, that's unusual. Am I taking the wrong dose? Maybe it's just a weird coincidence. Luckily, Sinclair's research included another mice group, this time fat mice, that were put in a high-calorie diet. And they consumed high resveratrol versus low resveratrol. So again, we can measure the difference between those two groups. What have they found? Let's see the graph. As you can see, the gray line is HF, which is high-fat, low resveratrol. The low resveratrol group had a rough start against all other groups in terms of mortality. That was a short term, suggesting some unlucky genes. However, over the long term, you can clearly see that the low resveratrol group had the best survival over the high resveratrol group. And you can see the difference, the delta between high resveratrol to low resveratrol. High resveratrol is in red, and the red line is far below the gray line. These obese mice fed even a lower amount of resveratrol. And because they ate every day, the daily resveratrol dose is actually lower. Not to mention they were heavier, which also reduces the amount of resveratrol they receive per body weight. The interesting thing is, not only the mortality decreased in both low-dose resveratrol groups, but also the maximum lifespan, as you can see in this graph. Both in every other day feeding low resveratrol, in high-calorie low resveratrol, they had the longest living mice. In Sinclair's own study, low resveratrol worked better for longevity than high resveratrol. That was a surprise. I thought it's gotta be a mistake. What do these numbers mean to us? How does this low resveratrol in Sinclair's study translate to us in terms of the dose of the supplement that you and I take every day? So the first step in our investigation is deciding what is low resveratrol for us, you and I, so we could compare it to how much we should take. Maybe 1 gram in humans is actually low resveratrol. Let's calculate this. The first issue in Dr. David Sinclair's study is that they did not calculate the exact body weight to resveratrol dose. So they only measured their weight, the food, and the resveratrol amount per food. So what do you do here? The solution here is you need to find the weight of the mice, and then the weight of their food, and how much resveratrol was in their food, and then convert it to our human weight. I won't bore you to death with those calculations, so feel free to pause this video and read for yourself the calculation. The bottom line in this, in the first every other day feeding, according to Academy conversion, it's 88 milligrams of resveratrol once every 2 days for a 160-pound person. If you weigh more, then it's more. If you're thinner than that, then it's less than that. In the obese study, where the low resveratrol was even more successful, they only consumed 33 milligrams of resveratrol every day. That's pretty low. Based on those numbers, we can say that the lower resveratrol range is 33 milligrams and 89 milligrams according to Academy conversion. So here it is. We know the 1 gram that Dr. David Sinclair takes definitely falls into the high resveratrol group, not the low resveratrol group. But maybe it was an unusual result. Do we have other studies to corroborate what Dr. David Sinclair found in his studies? Now, I love everything they did in this study, everything, and how the researchers here think. Here is why. First, they put the resveratrol in food, just like what Dr. David Sinclair did in his study, and we know that this leads to the best absorption. So we have one check here. Then they analyze organs that we know resveratrol targets. They analyzed the muscles, the heart, and the brain, and they even operated the liver at the end. That's unlike other studies that measure resveratrol impact on the immune system, similar to what they did in the CRISPR study I mentioned in the previous video. And third, it's a complementary study to what Sinclair found. Dr. David Sinclair, in his study, let the mice live throughout their entire life. It was a lifespan study. But what they did, at a very old age of these mice, they measured genes of longevity, activations of genes of longevity. This is a fantastic insight and a fantastic screenshot into the genetic expression of mice because of resveratrol. Even better, they compared it to caloric restriction. Caloric restriction is a model that is proven, the most proven model for longevity. So they compare the genetic expression of low-dose resveratrol versus caloric restriction. So this gives us insight not just to corroborate whether what we found with Dr. Sinclair was a coincidence, but also to analyze the reasons of what happens behind the scenes in the mice studies in Sinclair. So this way we could understand how resveratrol works in the body. This study is called A Low-Dose Dietary Resveratrol Partially Mimics Caloric Restriction and Retards Aging Parameters in Mice. How low resveratrol they gave to them. I'm quoting, "This dose is approximately equal to 4.9 milligrams resveratrol per kilogram body weight, assuming a 35-gram mouse. This equals to only 30 milligrams of resveratrol for a 160-pound person." This is how they analyzed the mice, as I explained. Mice were sacrificed at 30 to 31 months of age, tissues collected for gene expression analysis. We focused our analysis on 3 tissues: heart, skeletal muscle, and brain. This is what they found. Heart. There were 1,029 genes that were significantly changed in expression with age in the heart. Surprisingly, resveratrol opposed 947 genes of age-related change in gene expression. So we're talking about aging genes that turns on as we age. We don't want these genes to turn on. We want them to be silent. And they also found that this correlated well with what happens with caloric restriction. So resveratrol, as well as caloric restriction, turn off aging genes in mice in the heart. Then they go to muscles. They found the same thing to a lower extent. Aging resulted in alteration of expression of 515 skeletal muscle genes. 26% of them were significantly opposed by caloric restriction and resveratrol. The same result, silencing of aging genes. In the brain, the same result to a lower degree. In the neocortex, caloric restriction and resveratrol significantly inhibited 13% highly significant age-related changes in gene expression. In addition, the researchers also measured the longevity genes, not just aging genes, and they saw the same result. Resveratrol activates certain longevity genes in the same way that caloric restriction does. But the main highlight here is silencing the aging genes. What I also loved in this study, that they also operated the heart and internal organs to see the impact on health span and also on cancer. We're going to speak about this later. But let's see what they found about the condition of the heart. Heart performance in old age. Both caloric restriction and resveratrol supplementation almost completely prevented the age-related decrease in this parameter. Resveratrol mimics the effect of caloric restriction to prevent cardiac aging at both the transcriptional and functional level. In essence, resveratrol helps the heart to stay young both in the performance aspect but also the genetic expression, which is extremely important. The researchers concluded, "Our studies suggest that dietary consumption of low-dose resveratrol partially mimics caloric restriction and inhibits some aspect of the aging process." I want to stop here before we continue to gather the insights from this amazing study. So let's connect the dots. What bad diet and a large belly fat does? Turns on aging genes, and resveratrol turns off aging genes. This study also confirms what Dr. David Sinclair found about SIRT1 activation. SIRT stands for Silent Information Regulator, and we can see here evidence how resveratrol keeps those unhealthy aging genes silent. And this explains beautifully how resveratrol is so effective in obese mice, because not only their diet activates these aging genes, but also their belly fat. And this is very similar to people that you know who have a large belly fat and eat high junk food diet. They benefit the most by resveratrol because resveratrol offset the activation of these aging genes. All these benefits came from low-dose resveratrol, translated to less than 30 milligrams for a 160-pound person. This confirms exactly what Dr. David Sinclair found in his study. We can also conclude that the obese mice, junk food with big bellies, have the most to gain from resveratrol. But as Sinclair found, it won't prevent the excess weight. So resveratrol doesn't prevent us from gaining weight, but it just turns off the aging genes from our bad diet and big belly fat. Another amazing insight that we have is explaining the longevity benefits of the mice who took resveratrol day on and day off, and who fasted in between. Now think about this. How did these mice on the every other day feeding consume resveratrol? It was put into their food. So when they fasted, they didn't receive resveratrol, but they did not need resveratrol because the fasting already silenced the aging genes. The next day, they overindulged in food. They ate excess amount of food. This is where those excessive meals turns off longevity. But resveratrol was in the right place and the right time to turn off these aging genes. This what gave the reduction in mortality and possibly the 2.5 increase in maximum lifespan. And remember, these mice only consumed resveratrol for half of their consumption days. So that was enough for resveratrol to reduce mortality because it was taken in the right time. Have you wondered about what's the best timing to take your resveratrol? So we got a hint exactly here. This also gonna help us later and suggest that the timing that we take resveratrol is critical. Here is a summary so far of these 3 studies with excellent longevity results. Obese mice everyday feeding. The most successful dose is 33 milligrams per 70 kilogram person. Every other day feeding has the most successful dose was 89 milligrams for 160 pound person. And mice with genetic expression tracked at old age with everyday feeding had a successful dose at 28.5 milligram per 160 pound person. So this is low resveratrol and it's very effective in mice for longevity. So far we have greater confidence that what Dr. David Sinclair found in his study was correct. Low-dose resveratrol works in mice for longevity. But these, you may say, are just mice. Sure, mice are our evolutionary cousins. But what about us, humans? Do we have any evidence that low resveratrol actually improves longevity? So here we have a challenge. You see, it's impossible to make a similar study in humans. It's impossible to track humans for 80 or 90 years while taking all along low levels of resveratrol versus high levels of resveratrol. So how can we overcome this problem? One of the known benefits of resveratrol is that it reduces blood sugar. So the first question is, what happens if you take a human cell, put it on a dish and expose it to low levels of resveratrol? Would it react by reducing its sugar levels? This study take a look in exactly that. I'm reading from this study. Resveratrol long-term treatment differentiate INS beta cells towards improved glucose response and insulin secretion. Beta cells are human pancreatic cells isolated on a dish. The data demonstrated that chronic exposure to low-dose resveratrol expands the range of glucose dose response of INS-IE cells, of these pancreatic cells. These human cells, deprived of resveratrol, returned to the phenotypes of naive cells. In other words, they lost the improvement of response to glucose. So low-dose resveratrol was enough to improve response to sugar by human cells on a dish. This is good. Okay, so this is the beginning point. What about the human body, the entire human body? So we don't have lifespan studies in resveratrol as I explained. However, you and I are part of a massive experiment that includes low-dose resveratrol, and it's highly researched. You know what it is? Red wine. What is red wine? If you take red grapes and mix them with yeast, the yeast turn on the sugar into alcohol. That you probably know. This is no different than making a beer out of grains. But that's not everything that happens here. Grapes, especially red grapes, and yeast are not the best friends. So the grapes trigger their defenses as a response to the yeast exposure. The grapes, as a defense system, produce these low levels of molecules called polyphenols. These polyphenols help the plant, the grapes, survive and stay alive. So red wine is essentially a concoction of plant polyphenols dissolved in alcohol. One of those polyphenols is resveratrol. The question now is red wine a good model for low-dose resveratrol in humans? For that, we need to answer 2 questions. One, how much resveratrol is in red wine? And the second is, maybe the alcohol is really the main benefit here and not the polyphenols, if there is any benefit in red wine. So let's begin with the first question. how much resveratrol is in red wine? This study, called Resveratrol, How Much Wine Do You Have to Drink to Stay Healthy, says, I'm quoting, the average red wine can expect it to contain 1.9 plus or minus 1.7 milligrams of trans resveratrol. By the way, trans resveratrol means resveratrol. The trans part simply means that it's the active molecule that wasn't damaged or oxidized. So we can say that in about 200 milliliter glass of red wine, you get about half a milligram of resveratrol, together of course with other polyphenols. So if you drink just one glass of red wine, or if you're a moderate red wine drinker and you drink one glass every day, you receive about half a milligram of resveratrol. This is very low dose. So that answers our condition. Red wine is a low dose resveratrol. Then you can say that red wine is not a good model for low-dose resveratrol because it also includes alcohol, and there are many studies that speculate whether alcohol is beneficial for human health. Maybe it's the alcohol that possibly caused whatever benefits from red wine. So this study from 2021 has a clue. When you compare red wine to white wine, red wines contain roughly 3 to 10-fold more resveratrol than their white counterparts. And the authors of this study noted that the cardiovascular benefits occur only in red wine. I'm quoting, cardiovascular beneficial effects were observed in humans after ingesting red wine daily for 4 weeks. However, this did not occur when white wine was used. So this gives us a hint that it's not the alcohol, it's the polyphenols. Soon in this video, I'm going to show you more evidence that alcohol isn't the cause of the benefits of red wine, it's the polyphenols. So let's agree that red wine is a good model for low-dose resveratrol in humans. It has a low dose of resveratrol, and it's not the alcohol that is responsible for whatever benefits that we may see. So we cannot track humans for 80 or 90 years, but we can measure the activation of longevity genes and pathways in humans. This terrific human study in 2021 did exactly that. They took nuns who did not drink red wine in the past 2 years and gave them red wine. But why did they choose nuns? I'm quoting for their reason. The only population that can be strictly controlled are monks and nuns who live in the same environment with the same routines with the controlled diets. So because their lifestyles are repetitive, known, and similar amongst all nuns, this is a great study for humans. So they gave them 2 glasses of red wine per day. Each glass contained 200 milliliters twice a day. They took it at lunch and at dinner. Let's see what they found in this very interesting study. Moderate red wine consumption increases the expression of longevity-associated genes in control human population and extend lifespan in fruit flies, 2021. Okay, so the goal of the study was to investigate the effects of moderate red wine consumption on the expression of longevity-related genes. These were the findings after 2 weeks. The first thing they saw, I'm quoting, 2 antioxidant genes, catalase and superoxidase dismutase, were upregulated after red wine consumption for 14 days. So the first result was longevity genes of antioxidant defense were activated. The second thing they found, I'm quoting, an increase in the expression of important genes involved in aging like p53 or SIRT2-in-1. So they found more longevity gene activation. SIRT1, this is what Dr. David Sinclair researched, and p53, which is a cancer protection gene. Both went up. The third result they found, moreover, due to the important role that the immune system plays in the aging process, we determined the values of interleukin-1 and found that it was upregulated only in some of the nuns. The results were statistically significant. So the third result was another biomarker of aging, inflammation. It went down significantly in 70% of the nuns, probably a genetic variation between the nuns. So these were the results, but the researcher didn't stop there. They also want to measure lifespan, but we cannot do that in human because you have to track them throughout their entire lives. So what they did, they gave fruit flies a modality of aging, red wine. Let's see what they found there. I'm quoting, for obvious reasons, longevity intervention studies cannot be performed in humans. We took 300 flies and 10% red wine was added to their diet. The difference between the 2 curves show a significant increase in the average lifespan of 7%. Maximum lifespan was not affected. Now, I want to stress this point. When you reduce mortality, you can increase the average lifespan. More flies lived longer, but it did not increase the maximum length of which every fly could live. Does that make sense? This is reducing mortality, and it's a very important component of aging. Now, I told you I want to show you further evidence that it's not the alcohol, it's the polyphenols in red wine. Let's see what they say in this study. In fruit flies, at least non-alcoholic wine was better than ordinary wine in terms of lifespan promotion. What they say here is also interesting. Our nuns refused to take the non-alcoholic red wine. I found that quite funny, actually. And the researcher concluded, de-alcoholized wine may point to the damaging effect of alcohol itself on the general health of individuals. So this was one of the most fascinating studies I've read on red wine, but there was another one that also examined exactly what we want. Do the low-dose polyphenols and the low-dose resveratrol in red wine activate longevity genes in humans? This study is from 2014. What I like about this study, including the previous study, that both were conducted in healthy people, just like you and I. Unlike many studies on resveratrol that are done on unhealthy, sick individuals, which really change the metabolism of the individual and the goal of the study. Let's delve into the study. So this study is called Intake of Red Wine in Different Meals, Modulate Different Aspects of Aging, including Gene Expression. So let's see what they found in this study. We evaluated the outcome of consumption of different meals with and without the additive effect of red wine. A total of 24 subjects, meaning they took 24 people, were analyzed for OX-LDL, catalase, GPX1, SOD2, SIRTUIN2, and CCL5 gene expression levels before and after consumption. All of these are genetic expressions of longevity. This is what they found. When red wine is associated with different meals, values of oxidized LDL, which means oxidized cholesterol, are lowered. This shows an expression in antioxidant genes is increased, while CCL5 expression is decreased. In other words, what they found that red wine, again, increased the activation of longevity genes that are responsible for antioxidant defense of our bodies. They also found that GPX1 increased significantly in the comparison between baseline and all conditions with red wine. The bottom line of this study is that all the longevity genes they measure, besides SIRT2, were activated by low-dose polyphenols in red wine. Let's get back to the core of the investigation. We've been seeing definitely that very low dose of resveratrol from red wine with additional low-dose polyphenols is enough to activate longevity genes in humans. These were similar to the mice studies in resveratrol. So here you have it, the second clue that low levels of resveratrol, especially in synergy with other polyphenols, work in humans too. Maybe by taking our resveratrol with a bit of red wine, we'll get also this synergetic effect. Besides humans, we also have seen that this low dose of resveratrol in wine also increases the average lifespan in insects, just like in mice where it reduces mortality in both Sinclair studies. So far in our investigation, we have found that in both Dr. David Sinclair studies, low-dose resveratrol worked better for longevity than high-dose resveratrol. This was further supported by another mice study 2 years later, showing that as little as 28 milligrams of resveratrol activated longevity genes in mice. We also have seen that in humans, very low-dose resveratrol in red wine with other red wine polyphenols was sufficient to activate longevity genes and pathways. This result was repeated and confirmed in an additional study. Also, the red wine with low-dose resveratrol was enough to increase 7% the average lifespan in fruit flies. And we also have seen in human cells that low-dose resveratrol was enough to elicit a longevity response by reducing sugar levels inside the cell. So you see, this molecule seems to be much more powerful than we ever imagined, triggering all those longevity responses in surprisingly low doses. So together we can say that low-dose resveratrol increased longevity in humans, animals, and insects, suggesting that what we have discovered in Dr. David Sinclair's study is spot on. But then you may ask, if low resveratrol works so well, if we take more, maybe we'll achieve better benefits, better results for longevity. Great question. For that, ideally, we need to search for a study that compares different doses of resveratrol in humans, but we only want to target now resveratrol alone, without the other polyphenols. Do we have such a study? The perfect study for us would examine 4 parameters. One is going to examine resveratrol as a lone supplement, without its polyphenol friends like in red wine. The second thing is that we need the study to be done in humans. And we need massive amount of data. We don't need just 12 subjects. We need hundreds or thousands of subjects. The third thing that we really need is to compare different doses of resveratrol. Now, if you ask me, I would rather have the lowest group between 50 milligrams to 100, 120 milligrams comparing to higher groups like what Dr. David Sinclair takes, gram or less. And the fourth parameter I want here is a study that measures longevity pathways and genes. And if possible, we're going to cover another aspect of longevity that weren't measured in the previous studies. 2 of these longevity pathways, which we have not examined yet for resveratrol impact, are insulin and blood sugar. You probably know that sugar level is important, but what about insulin? Insulin is a hormone, and both insulin and sugar levels affect our healthy metabolism. They also affect our chances to develop diabetes, one of the largest 3 killers in our society. So certainly you agree that low blood sugar and low insulin are very important for health. But why do we care about blood sugar and insulin for longevity?
Why is it that having elevated blood sugar, glucose, and insulin ages us more quickly?
The group of genes that I work on are called sirtuins. There's 7 of them. And we showed in 2005 in a science paper that if you have low levels of insulin and another molecule called insulin-like growth factor, those low levels turn on the longevity genes. One of them that's really important is called SIRT1. But by having high levels of insulin all day, being fed means your longevity genes are not switched on. So you're falling apart. Your epigenome, your information that keeps your cells functioning over time just degrades quicker. Your clock is ticking faster by always being fed. There's plenty of other reasons as well that are not as profound, such as having low levels of glucose in your body will trigger your major muscles and your brain to become more sensitive to insulin and suck the glucose out of your bloodstream, which is very good. You don't want to have glucose flowing around too much. And that will ward off type 2 diabetes.
I want to show you what Dr. Ron Rosedale says about blood sugar and insulin. Dr. Ron Rosedale is a worldwide expert on insulin, sugar, and aging. Let's see what he says in his presentation in front of hundreds of doctors. Now, here he spoke about centenarian studies. Centenarians are humans who lived over 100 years. You would think that with all the technological advancement we have, these people are common. But today, only 20 people out of 100,000 people passed that mark. It's only 1 person in every 5,000 people. They are rare. Now let's see what Dr. Ron Rosedale says about them. He asks, why do centenarians become centenarians? Why are they so lucky? What are the commonalities of centenarians? I'm quoting from him. What researchers are finding from these major centenarian studies is that there is hardly anything in common among these people. However, they all have relatively low sugar for their age, and they all have relatively low insulin. He also said, in humans, the rate of mortality doubles every 8 years. We found in animal studies that the rate of aging can be largely controlled by insulin. So insulin and blood sugar matter. And when I say blood sugar, I spoke both about fasting blood sugar in the morning and also A1C, the average blood sugar in the last 3 to 4 months, as I explained. Both represent blood sugar levels. Now that we understood the importance of insulin in blood sugar for healthy metabolism and for controlling our rate of aging and our longevity, let's get back to our investigation. So, we were looking for a large human study that tested different doses of resveratrol against aging parameters such as blood sugar and insulin. This way we can see if higher doses of resveratrol give us better results. This could possibly explain why Dr. David Sinclair takes 1 gram per day. Do we have such a study? In 2019, when I delved into resveratrol, I haven't found such a study. But luckily 2021 came. And with it, a new human study that is close to what we want. Not perfect, but close. This human study was a review study that included many other studies on resveratrol. In fact, all the known knowledge that we have on this supplement in human in different doses. Let's see what we can uncover from that study. We will discover how resveratrol affects, in different doses, 3 critical keys that keep your body younger for much longer. This will come from a terrific 2021 human study that gathered all known data for those 3 keys for health and youthfulness, comparing it for different resveratrol doses. The name of the study is Hypoglycemic Effect of Resveratrol, a systematic review and meta-analysis. Before we delve into the study, let's talk about the strengths and the weaknesses of the study. One of the biggest strengths that we have is in updated data. It's a study from 2021, and it looks backwards, exactly what we need. The second is they have a massive amount of data in humans, and they filtered this data very properly. They filtered the 30 best resveratrol studies out of the 1,200 studies in humans. The third thing that I really like about this study is that they use resveratrol as a lone supplement. If resveratrol was included with other supplements, they discarded the study. So that's very good for our investigation, to separate the effect of other polyphenols from the one of resveratrol. The fourth thing they did, they compared different doses of resveratrol, exactly what we need. However, the weakness here is that the lowest group was below 500 milligrams. They used 3 groups, below 500, between 500 to 1000, and 1 gram and up. Ideally, as I said, I would much rather have a group that has between 50 milligrams to 120 milligrams. But this is as close as we can get, folks, so we're going to use what we have. And the fifth, very important thing they did here, they examined 2 longevity markers that we haven't touched yet. Insulin and blood sugar. That includes fasting blood sugar, the one that you wake up with, and the second is A1C, which is the average blood sugar in the last 3-4 months. That's not bad at all, because this is another aspect of longevity that we did not cover today. One of the weaknesses of this study that they mainly revolved around ill people. That's where the money goes, folks, not for longevity. Let's see what they found in the study after analyzing all the human data on that subject to this point. Hypoglycemic Effect of Resveratrol, a systematic review and meta-analysis. The first finding is resveratrol dose in humans, fasting blood sugar. They found the greatest reduction in blood sugar took place under 1 gram of resveratrol. When you go over 1 gram, suddenly you lose the benefits. However, it's not statistically significant. But we do have the first clue that 1 gram or less is sufficient to reduce glucose, and there is no big difference between the over 500 to less to 500 per day. Let's go to the second study findings. Resveratrol dose in humans in 3 to 4 months blood sugar levels, A1C. So what we see here is that less than 500 milligrams per day works for the average blood sugar for A1C. So we know that less than half a gram works for longevity. The other 2 groups were not statistically significant, so I don't want to touch them, but we do have confidence that less than 500 is sufficient to improve A1C. And to me, A1C gives us a much broader view of glucose levels. This is why I think it's even more important biomarker, and we know it works for less than 500 milligrams. The third finding of the study has to do with resveratrol dose in humans on insulin levels. To me, this could be the most important biomarkers of aging this study has examined. So let's see what they found here. Less than 500 milligrams per day, the lower dose of resveratrol, actually lowered insulin the most. This is great. You want your insulin levels to be as low as possible, which activates longevity. And both the lower dose and the highest dose were statistically significant. The weakest result achieved between the 500 to 1 gram per day, but it was statistically not completely significant, so we have less certainty about this result. The bottom line is this: the largest improvement and statistically significant in insulin took place under 500 milligrams resveratrol per day. Even more interesting that actually insulin improved more with younger, possibly healthier people. This is more relevant to us. So the people who were younger as indication of health. Remember, those people were sick, most of them, had the best improvement in insulin. Now, there is another insight from this study that you can use to implement in your lifestyle and also to manage your expectations from certain supplements, especially resveratrol. Let's see what they found. They compare results in studies that took less than 3 months versus studies that took resveratrol over 3 months. And both in insulin and A1C, you can see that the people continue to improve when resveratrol was used over 3 months. And most of these results were statistically significant. So what are the insights from this study? The first one is that resveratrol reveals its benefit in the long term. This is important when dealing with contradiction in studies. It's also important for our expectations from resveratrol, and it really makes sense when you think about it. Aging is a long process, the longest process that happens to us every day. So how can we expect to judge resveratrol, a longevity supplement, in a short period of time? It's not fair. You can actually apply this principle to any longevity supplement because at the end of the day, we are targeting a process that is very slow. So we need to look at a long range of time for these supplements. Another interesting cause for conflict in studies in resveratrol is measuring A1C, the average blood glucose, for 3 to 4 months, and taking resveratrol for less than 3 months. That doesn't make any sense, yet I've seen studies over and over concluding that A1C wasn't improved by resveratrol. So I want you to see how we have to interpret studies correctly to reach the right conclusions. Interpretation of data means everything. The third insight that we can take from this study is that it seems that lower resveratrol seem to work better for insulin and for blood sugar. My interpretation is that the lowest resveratrol group achieved the best result and the most certain result both in blood sugar and insulin, and they took less than 500, half a gram per day. And also remember that the lower dose resveratrol in this study was pretty high, less than half a gram per day. And let me remind you that today I showed you a study that showed that taking human cells, pancreatic cells, and expose them to sugar and resveratrol at a very low doses still reduces sugar. So who knows at what level would we achieve the best benefits with insulin, blood sugar, and resveratrol? We can say that this study that took different doses of resveratrol and measured the impact on insulin and blood sugar also corroborated what we found in Dr. David Sinclair's study. Low resveratrol is sufficient to achieve the impact that we want. And high resveratrol isn't better than low resveratrol. And we found inconsistent results with high resveratrol for insulin and blood sugar. So far, it looks like the most popular resveratrol researcher, David Sinclair from Harvard, is wrong about the dose that he himself takes. However, there is more to this fascinating story, which we will cover in the next episode. Until that, please share this video and subscribe to the channel to have a long-term, in-depth free education on longevity, because the correct data interpretation means everything.